All right. Hello, everybody, and welcome. Once again, we're getting a bit of a late start tonight. Had some more technical issues. I'll talk about that in just a second. But before we do, I just want to mention that we're going to pick up where we left off last night, and that is going to be with our Bespoke renderer. Before we get into that, though, just want to take a quick second to thank our elite partners, Javier Alazaran, and our partners Gorbolis Inc. and Matt Oscard. Those are the highest tiers of subscription over on Patreon and YouTube memberships. Followed by the list of supporters you see here on the screen. They're a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. That support helps me cover the cost of running the channel. Things like hosting fees, software licenses, stuff like that. So it is very much appreciated and helps me a ton. However, I do not want to fail to give a big thank you, rather, to all of you guys, the viewers, who are either joining us live here on Twitch or YouTube, or if you're just catching the VOD after the fact. Thank you guys very much for being here, because without you guys, this project and channel would not exist. So thank you. All right. So, what we are doing tonight is we are continuing on our sort of bespoke renderer, as we're calling it, right? So it's the application-specific renderer. And for those of you who have been following along, you might notice that I'm using a completely different theme tonight, and some things look a little bit weird. That is because I made the mistake of updating my Neovim plugins. And let's just say that stuff broke everywhere. It's amazing that I actually have it working. It's one of the most frustrating things about using this editor, unfortunately. And it's really making me want to kind of go back to my side editor project, so that I don't have to worry about things breaking like this all the time. And to be truthful, though, this hasn't really been a problem for quite a while. I've been pretty stable on this installation for quite a bit. I went to go change something and accidentally updated all my plugins, triggered that, and that has not gone well. So unfortunately, that is just the way that it goes sometimes. But so I'm using a little bit of a different theme here for now, but we'll figure it out. I'll finish fixing any issues that come up offline. But if you see a little bit of weirdness tonight on here, it's because of that. So I think I've got most of it figured out, but yeah. All right. So where we left off last time is if we take a look actually at the application config, and then we do the render graphs. If you take a look down here, we've actually got all of these guys done, right? So we're kind of working our way through recreating all of these in a bespoke renderer, right? So we finished up the forward pass, and then we also, last night we did the frame end pass, and we're doing the standard UI pass now. And that is because I think these two, the debug and the editor Gizmo, are going to be pretty straightforward to do. And so I've just gone ahead and decided to tackle the standard UI first, since it's more complicated. All right. Luna Moon, how's it going over there on the Twitch side? Good to see you. Let's see. Over in YouTube, I've got a question. I have a question about transform manipulator rendering. How does Blender Unreal Editor renders them without distortion when they are closer to the screen edges? Can't figure out how to achieve the same effect. Okay, when you say transform manipulator rendering, what do you mean by transform manipulator? Do you mean like the actual Gizmo that's on the screen, like the 3D Gizmo? Or do you mean something else? Because that could mean a few different things. Okay, so in here, we do have a bit of a to-do here as well. We do have quite a bit of logic in here for the standard UI itself. So at some point I do want to kind of get rid of those. But for now I'm just going to kind of move all the data structures over so that we can just kind of get this working, right? So let's see. Let's get the... Actually, I thought I already did all of this, didn't I? No, apparently I did not. Okay, I'll add fix me's just like we did up here, right? So we need a couple of structures. So we need the UBOs, right? Which is going to be essentially the same thing as what we had here, right, for the skybox. So we essentially have the same problem in both places. So I'm just going to throw in a couple of fix me's here. So we're going to say per frame SUI UBO fix me. This should be with the SUI files, perhaps. And that, well, maybe, right? Because it's not, although it's not used outside of here, right? And I guess that's kind of the same for all of these, right? The skybox shader, I guess, uses it, so maybe runtime, right? And then maybe SUI kind of goes with the standard UI, right? Because the shaders do know about it. I don't know. We'll have to figure that out. But I'm going to copy that and copy pasta that comment here a couple times, and we're just going to say per group and then per draw. Magetz, how's it going? Good to see you. Welcome. All right, so we've got these types here. So that is good to go. Now we need to convert this to renderer. And then SUI shader is going to be SUI pass SUI shader, right? So we're probably going to have to do that a couple of times. Renderer, SUI pass, SUI shader. And I'm sure there's probably going to be a few more of those in here. Yeah, here's another one. Here is another one. Here's another one. Right. I guess I could just highlight them, right? So we've got that one. We don't have this one, so we need to replace that. Replace that. Replace that. Just a couple more, it looks like. Yeah, okay. So that takes care of that. And then we've just got a couple of other things here. So projection. Let's see, do we have, I don't know if we have anything in the SUI pass for projection, but we'll see. So we're actually going to want render data, SUI data. Oops. Projection, we do have it. Perfect. Okay. So there's that. And then this is probably going to wind up being the same thing. Render data, SUI data, view. And that should be an arrow. All right. You do mean gizmos. Okay. So let me reread your question. So how do they render them without any distortion when they are closer to the screen edges? So they render theirs a little bit differently than I render mine. I actually have to fix how mine are rendered. Let me launch Blender so that we can actually see what you're talking about. All right, so you were talking about this guy, the transformation gizmo. So theirs works a little bit differently than mine does. Let's see, when we, oops. When we, where did it go? What did I press? What did I do? Why won't it not let me select anything anymore? It won't give me a gizmo. Why? What did I press? My gizmo disappeared, and I'm not sure why. What did I hit by accident? It's selected, but I can't do anything with it. I'm in an object mode. Oh, maybe I need to be... No, it's not that. Oh, I'm animating. You're right. There it is. Okay. I didn't even see that moving down there. Okay. So, I guess, let's see. How do I... Oh, that's why I hit spacebar is what I did. Like a dongus. So when it gets close to the screen, I guess I updated Blender and it like reset all of my factories or my my movement controls apparently, which is why I'm so thrown off here. Why can't I? My hotkey is not working for that apparently, but okay, all right. So I think what you were asking is like when it's near the center or near the edge of the screen like that, right? Where it's kind of going off the edge of the screen. You're asking why it doesn't like deform? What do you mean by screen edges, I guess? Like, do you mean that, or are you literally talking about like when you zoom in and out of it, it maintains the same scale? Okay, so there's a couple things. There's a couple things going on here. So the way that this works is the scaling. The scaling's not affected because of essentially we find out what the 2D coordinates are on the screen via unprojection, right? So we just basically unproject where the transform of this the currently selected item is. And that gives us the 2D coordinates, and then we just snap the gizmo to that, right? So the gizmo is essentially rendered at that screen coordinate instead of in world space like I'm kind of doing right now currently. So from there, all they're really doing is, I believe they're just doing, this doesn't even look like geometry. I think they're actually just rendering flat shapes like on the screen. It doesn't really look like geometry. So there's that, and really all it's doing is it just, when you get to the edge, it just clips down here, if that's what you're asking. So all it's doing is just clipping off. So I'm not sure how it would have any distortion. Unless the distortion you're talking about is because of the FOV. Like if you had a larger FOV, or a more extreme FOV, then you would get distortion of your 3D environment. But if you're rendering this in 2D, like what they're doing here, where it's literally, it looks like a 3D shape, but it's actually just flat on the screen, like rendered on top of everything, then you won't get that. Yeah, so FOV should not apply to your gizmo at all. So, okay, it took me a minute to kind of drill down to what you were talking about. So FOV only applies to 3D scenes, right? And the way that the Gizmo works is you're actually rendering the Gizmo in 2D as part of, almost as part of the UI on top of the scene. So it looks like it's 3D, but it's actually not. It's just an overlay that sits on top of it. So you take the 3D coordinates, you unproject those, basically undoing or inverting all of the transformations that you made to get this cube to where it is on screen. You invert all of those all the way up, and then you use those 2D coordinates to actually just slap it on the screen. So it's no different than like drawing a sprite in this location. Instead of drawing a sprite, though, you're drawing a few different things that you can interact with, a few different shapes, right? But that's really all it is. Like, you're not actually drawing this in 3D. So if you bear that in mind, then it becomes quite simple to actually do. Another thing that you could do is, if you want to generate this in 3D, you could generate this in 3D sort of off screen to another texture and then blit that texture on here, or render it to a quad or what have you. So there's multiple ways to actually handle this without, doing a render doc. I couldn't tell you exactly what they're doing, but those are kind of some of the ways that you would handle it. And that's also going to give you the consistent sizing, when you zoom. So I hope that makes sense. 3D projected, but with constant depth. Yeah, I don't know, actually. Let's see. I have a search feature under spacebar. Was set in Blender 2.8. I relearned Blender inputs when the 2.8 change happened. Yeah, like I got a prompt actually that told me like, hey, import your settings from the last version, and then it just like didn't do it. So I don't know what happened there. But anyway. Okay. Yeah, 3D projected with constant depth, I suppose could be another way to do it. All right. So now we have the location. So this is going to be renderer SUI pass. And then it's going to be frame UBO location. And then, oops, we actually missed one of these. So this should be renderer SUI data, SUI shader. Oh wait, not data, pass. Okay. DRA length. So this is going to be, wait a minute. This is actually going to be render data just by itself. Render data. Let's see, do we have, I guess I'm going to call it SUI data. Do we actually have our renderables in here yet? I don't know that we do. I don't think we do. So we'll have to fix that. I don't think we added that to the structure yet. So that's definitely going to be part of this render data. Yeah, we don't have that here yet. So this is kind of what I don't want here, right? So, oops. I guess this is okay. I'm going to actually not do this. Yeah, I'll include this here, but I'm going to take this and go over here. And I'm going to come down here, and we're going to just forward declare this, right? So I don't have to include the header. So I'm just going to go struct, and then grab this. Right, and then actually I should probably move this to the top. Yeah, like we've done here. Right, so we'll forward declare that, and then I can come down here and use struct, and here we'll say renderables, right? And that'll give us the renderables that we can then iterate through. Why does it not like that? Oh, I put it in the wrong spot, didn't I? No. Did I? No, it's in the SUI pass render data. What did I do? SUI data, renderables. It's right there. Why is it not picking that up? Okay. Anyway, let's see. We don't have DRA for one thing. Oh, it was bleating about that. Okay. We didn't have DRA in here. Do I really want a DRA as part of that? I don't think so. I think we're going to go with just a standard array, right? So let's do renderable count. Right? I really don't want to have to use derase for this if I can avoid it. So let's do renderable counts, and then we'll go back to the top and remove that DRA. And okay, that's better. So now we'll do render, whoops, I guess we just do render data. SUI data renderables sub I. And let's see what we have. I don't know why this is bleating about this, but okay, that seems fine. Okay, so here, all we need is the renderer, rather. So renderer, actually, let's just do that. That way we could just do a repeat here. Are there anywhere else where we'd have that renderer call? Yes, there's one more there. Okay. All right, so I think the rest of these are probably going to be location stuff. So I'm just going to shove this other buffer to the side for a second. And we want, let's see, renderer. And then we're going to do SUI pass, and then draw UBO location. So that's that one. And then we've got a couple more here. So we'll do renderer SUI pass, and then group UBO location. Okay, renderable atlas override. So this is going to be, I think we said we were going to provide this as part of the, was it in the state? No. Okay. Render data, SUI data, UI Alice. I thought so. Okay. So we have renderer, SUI pass, and then atlas texture, that's going to be location. And then we pass in the atlas, right? So here we're just deciding, does this renderable use the default atlas, or does it have an override? If we have the override, we use that. Otherwise, we use the default atlas. And then here we have renderer, and then this is going to be SUI pass, and then it's just going to be draw UBO location. And I think that's it for the standard UI stuff. Relatively simple stuff, right? Pretty straightforward. We still have got some to-dos in here and some things to fix, but we can move on for now. Let's see. I think it's 3D projected because the Gizmo has 3D shapes like arrows and cubes, but they are just shaded without lighting. Yeah, it could be. It very well could be. That's probably the way I would do it, to be honest. The Neovim syntax highlighter has a hard time with compound literals sometimes. So this is a new issue that popped up after I updated TreeSitter. So unfortunately, and I didn't realize this, the main branch of TreeSitter is like a completely different implementation than the master branch, but the master branch is no longer being updated. So it's sort of deprecated, kind of, or half deprecated. And so I had switched over to that because a lot of the other things that I am using interact with that newer version. But unfortunately, the way that TreeSitter does its highlighting groups specifically, are completely different than the way that was done before, so it breaks a lot of themes. But now this is kind of an annoying little thing that's happening now. Is what it is, I guess. Do you have any language server stuff going on? Language servers seem to be working just fine, thankfully. Those did not break, thankfully. But yeah, this happens every once in a while whenever I update stuff, and it just breaks, which is why I don't update it very often. It's getting a little tiresome, to be honest. So I may start working on my own editor again in my downtime. Or maybe we'll look at it on stream at some point. I don't know. But I do have something in the works for that. One reason I go minimal plugins too. Yeah, exactly. Like, I've been trying to reduce my reliance on them, but you know, for something of this size, like, it's really nice to be able to just say, you know what, I need to, you know, peek the definition of this and just have all this info right here. That's really indispensable when you're dealing with a project of scale. If it was just, you know, a few thousand lines of code in a small code base, you know, that wasn't really all that complicated, I wouldn't really care. But past that point, you really need something that provides that information. At least I do, I think. I can only commit so much up here, you know, and we're at like 80,000 lines or close to 80,000 lines in this code base, so. Okay. So the next one is going to be the editor Gizmo. I guess we'll do that, and then we'll do debug 3D. I guess I suppose I could do them in order too. So this one, let's just have a look here. I'll drag this over here so we can actually see it well. Create. Let's see, setup data. This is all just sources and sinks, so I don't have to worry about that. All that stuff can go away. Okay, so we do have a initialize, we do have a load resources. So I guess let's look at initialize first. So initialize literally just grabs the shader and then grabs a few uniform locations and calls it a day. Nothing crazy there. Load resources hooks up the resources from the sinks and sources. So I don't have to worry about that either. Execution also is pretty straightforward on this one, right? So execution is literally just going to be this. Not fond of the highlighting color of this particular theme. Doesn't really stick out very much. Anyway, so this one should be relatively quick then. So let's actually do the initialization first. So was it? It's create. Okay. And then let's go to the bottom here. And we're going to do, actually, you know what? I should probably do these in order. So this one's actually going to be here. And so this one is going to be debug pass state. right? And so this is for like our world debug information, right? So this goes over top of the world. We should probably rename this, right? So this goes over top of the world when we render it, but underneath the UI. And we'll probably eventually have a UI debug layer as well. We don't have it yet because we haven't done a whole ton of UI stuff, but at some point, that's probably what we're going to do. So I'm going to take this stuff, and we're going to go over here, and I'm going to have to set up a new structure for our what I'm going to call, I guess, the world debug pass. So let's go here, and let's go ahead and type def a struct, and we're going to call this Illumina world debug or debug world debug, I guess, pass data. Illumina world debug pass data. And to that, we are going to need obviously a shader, right? So khandle, and we're going to say, I guess we'll say color shader, and then we'll have a U16, and we're going to do projection location, U16, U16, not U26, view location, and U16 model location. And that's all we need for that, right? So that's pretty straightforward stuff. And then we'll come down here and add in right here world debug pass. All right, so here what we'll do is we'll say, actually let's just do this. So we'll do out renderer world debug pass dot. Right, so we've got color shader, and then we have, we can actually do projection location, view location, model location, and then all we have to do here is, I think we can actually get away with doing renderer world debug pass dot. Oh, it's out renderer. Dang it. All right. Yeah, I guess I'll do out renderer. Right, so out renderer world debug pass dot, and the same thing there. Right, so that should be all we need to do as far as that. Load the color 3D shader and get shader uniform locations. So cool. That's all we need there. And now the only other thing that we need to do is going to be, let's see, at the top of this. So we're going to say world debug pass. And this is going to be scoped as well. And then we're just going to go over here to this guy and take all of this all the way down here, all the way down to the end of the debug label. We're just going to move that over here. Right, and then essentially, make the properties line up to what they should be. You should name the editor Code, spelled Koed. That's funny. Kohi editor, but sounds like code. I don't hate it, to be honest, but it already kind of has a name. Which I guess the name itself was a bit of a joke, so it doesn't completely make sense, but, well, it does and it doesn't. I was calling it Notepad minus minus. Minus minus being it's going to be minimal, right? It's going to be lightweight, it's going to be fast, and not rely on plugins to give me what I need. It's a bit misleading. Kohi has its own level editor. Yeah, that's the other thing. Is Kohi eventually is going to have an editor application that I haven't named yet. So, maybe. Notepad to the power of -1. I love it. All right. So this was using internal data geometry count. So we actually need to... oh, you know what? We actually did not... we did not do the render pass data in here. So we're going to need a new struct for that as well. And this one's going to be really simple as well. So type def... struct Illumina no, not SUI, world debug pass render data, right? So it's render data instead of data, right? And the three things that we're going to need in here is going to be a mat for projection, mat for view, and a mat for model, right? So we're going to need those, and then we are going to need I think it's just straight up geometry data, I believe. Let's see. Yeah, I think, let's see. Geometry render data right here. I don't know that I want to use... I don't want to use this, right? I don't want to actually use this old geometry render data, right? I want to kind of not do this, because this includes a whole bunch of crap that we don't need. We're kind of deprecating and moving away from that one. So I think what I'm going to do instead is actually, I'm going to go back to the header here, and we had in here Illumina geometry render data, right? So this is kind of a lighter weight thing, right? So we're going to use these things, right? So we have geometry count and then a array of geometries. And so what that's going to give us is only the information that we need and nothing else. So here we can do render data. Oh, I didn't add the other thing that I need to add to that. So let's do this. I forgot to add the actual world debug pass render data. And we'll say world debug data. Right, so data to render world debug geometry. Okay. So render data, this is going to be world debug data geometry count, right? And let's see, we have this and this. Is this ever going to differ? I don't think it is. I think we can just use renderer color buffer and renderer depth stencil buffer. So we can just use those as is, and then we can do renderer render state here. We need render data VP rect, I think it is. Do we have... I might actually have to get that from, because I think that was under forward data, wasn't it? Yep. So we need a viewport. So I guess let's do that. So we're gonna need, all we really need for this is the viewport rectangle, right? Let's just do that, right? Because otherwise I'm gonna have to come back and refactor it later. So we'll do world debug data VP or viewport rect, right? Okay. Oh, this is why I didn't do it. Okay. I do need to refactor this, but not as part of this change. To do deprecate this and set viewport scissor on the renderer directly instead. All right, so let's go back here. Let's change this to viewport. All right, and we'll just change this to VP. So we'll do vp.rect. Okay, and then we'll do, as much as I didn't want to do that, world debug data VP rect. Why is this? Does it not want the address of that? Huh? What does this want? Yeah, it wants a pointer to a viewport. Why doesn't this like that? What am I missing here? Oh, because it probably doesn't know what probably doesn't know. I'm going to guess that this is probably... Well, it is there. It's the same literally as this. Why is this bleating? Oh, because I'm passing the rectangle, not the viewport. Because I'm a dingus. Dingus-oriented programming. It's a fraction of Notepad, so very minimal. I mean, I don't hate it, Magets. I don't hate the idea. Okay, so we've got a whole bunch of these internal data color shaders to replace. Now, I could do a find and replace on this. But while I'm refactoring like this, I like to go through each one individually so that I'm sure that I'm not screwing anything up. So we're going to do change two words. We're going to say renderer, and then world debug pass dot color shader. So let's just get all of the color shaders out of the way. oops, back one more. There we go. And we've got a renderer back here that we need to get rid of as well. This should be render.renderState. Okay. And then instead of internal data geometry count, right, we're going to do render data world debug data dot geometry count. And then instead of geometry render data, we're going to do Illumina geometry render data. And this is going to be the address of render data world debug data dot geometries. Wait a minute, why? Render data world debug oh, I called this render data. That's why. That can't be render data. That has to be, let's call this geo. And then this needs to be geo. And this needs to be geo. And then this we're going to get rid of here in a second. Okay. So let's fix these locations up here. So this is going to be renderer world debug pass, and then projection location. And this is going to be renderer and then world debug pass view location. And instead of internal view, that's going to be render data world debug data view, right? And that's going to be the same thing here. Projection, right? So we set the view projection, and then we have one more down here for model. So this is going to be renderer and then world debug pass model location, right? Okay. Geometry draw ID. Do we not have a draw ID on geometry? I thought we did. Oh. This does have a draw ID. Okay, so technically speaking, we probably don't need, well, That's annoying. Because geometry doesn't necessarily have right? It doesn't necessarily have a draw ID. How did I get around this with, oh, wait a minute. No, how did I get around this with static meshes? We have one for the skybox. Okay, that's all shadow pass stuff. That's shadow pass stuff. And then this is only here. So what did I do for... It's going to be unseen pass. That makes sense. Per draw. Okay, that's skybox stuff. Material per frame. We just drew it here without a draw ID. Apply instance. It's tied to the material instance. That's how I did it. Okay. Okay, so we don't have a material instance in this case. So we're going to have to come up with some other way to transport a draw ID over to here. So let's take a look at this. So we have geometries. I could do an array right beside it with draw IDs. What is that, a U32, I think, right? Yeah. So I could do that, because I really don't want to add draw ID to this structure because not every geometry needs it, right? The other thing I could do is I could create a structure that wraps this and then put the draw ID with that. That's probably a better way to do it, actually, now that I'm thinking about it. So let's do that. Type def. We'll go with Illumina. Do we want to do debug? Yeah, let's do that. Debug geometry render data. Illumina debug geometry render data, right? And so we'll take this, put that there. Oops, I forgot struct. And then this is just going to be, let's just call that geo, right? And then we'll do U32 draw ID, right? And then we'll use this structure down here, right? Which means we have to change a couple things in here, but that's not a huge deal. So Illumina debug geometry render data, which means we can directly pull the draw ID from that. And then here we just have to do geo model, right? And then here, when we actually get ready to perform the draw, I've actually got this logic elsewhere. So let's do let's see, buffer draw. Here we go. So we're going to take this. We're not going to worry about winding on this because we are not going to support inverted winding for this. Right, so instead of using this other structure that we're going to deprecate, in fact, I think I still have this marked as deprecated. Maybe not. But I want to get rid of this structure, right? So instead of doing that, we're going to do this. So this just needs to be, need to have the second level of geometry added there for that. And oh, this has references to Vulkan in it. So that should be All right. We've got that in there 6 times, right? So let's see. I guess let's just do that. I think we can do. Actually, you know what? Let me make sure that these are all that. Yeah, they are. Okay. So we'll do find and replace. We'll look in renderer. Draw geometry. And we're going to replace that with renderer, render buffer, draw globally. Okay. So that is going to be I suppose we could actually no, we can't reuse this. Okay. Not for that anyways. Okay. So now we can get rid of that, draw it, and I think we're done with that, right? So that's the world debug pass. All right. Oh, I have completely been like, I didn't hear the raid thing go off. Hypnotic Games raiding with a party of 35. Thank you so much. It's been a couple minutes. Good day, you get done. Thank you so much for the raid. Welcome, raiders. Sorry, I was like in the zone there, coding. Let me catch up on chat, but first, I'm going to give a shout out to Hypnotic Games. If you guys aren't following Hypnotic Games, do it. He streams basically every day, and he's always doing awesome stuff with Godot, so definitely check him out. Welcome, raiders. I will catch you guys up to what we're doing here in just a second. Thank you for the hydrate redeems and posture check. Must get lunch and do things before later stream, so lurk. Appreciate the lurk, Hypnotic. I appreciate that a lot. Thank you so much for the raid. Let's see. Multi-select and terminal. Goodness gracious, I love it. Yeah. It's pretty sweet. Let's see. Would that be just similar to sticking it on the end? I mean, I guess kind of in a way. If I'm thinking in JavaScript brain, which is different, I know. Yeah, fair enough. Let's see. First time chatter. Man, this is really inspiring, cool stream. Thank you very much for that. It's fine. I feel welcome. Yeah, I appreciate that gamer. Yeah, so looks like I've got a couple on the YouTube side too. Singy, how's it going? Good to see you. Actually, I think that's the only one I missed over there. So yeah, let me catch you guys up on what we're actually doing, because I know Hypnotic has talked about this once or twice on his stream, at least that I know of. But and I'll drop a link in chat real quick to this as well. Whoops, that's the wrong button. That one is what I want. Okay. Hitting all the wrong buttons tonight. All right, so this is the website for what we are building. So we are building what is called the Kohi game engine, which is a game engine written in C from scratch that uses Vulkan as its primary, or at least initial rendering backend. I say initial rendering backend because we do have support for DirectX and Metal planned for the future. It is cross-platform. It's available on Windows, Linux, and Mac OS. And so, we do support those desktop platforms with plans for other platforms in the future, right? We do eventually want to support mobile and consoles as well, to some degree. So the engine itself is open source. It's all available on GitHub. It is open source and free. It is Apache 2.0 license, which means that you can use it for whatever you wish, whether that's personal or commercial. Does not matter. All that I ask is that if you use it, give credit and say you used it. That's literally it. So this engine is being built as a sort of educational exercise And so we do a lot of experimentation and exploration on this channel. And we are going through the complete process of making a game engine and thus a game on that game engine, at least one game, probably multiple. And so we're going through that process start to finish being we release a game on Steam. So we've been primarily building the engine for quite a while now, and we're actually starting to switch gears towards the actual game side. But we're kind of ramping up for that now. So just to put this into perspective, everything having to do with the engine will always be free and open source. There will never be any sort of royalties or license fees of any kind. It's designed to be an educational exercise, and I think that stuff should be free. I think competition in this space is sorely needed, and I'm hoping to inspire people to want to get into engine development because I think competition drives ingenuity, and I think we really need that right about now. So that is basically the spiel, right? So the website here has a bunch of links on it. So it's got a link to obviously the YouTube and Twitch where we stream. Discord, we've got about 1,000 people on that, a little over. And then of course GitHub, and then I've got a link here to Patreon. I don't have any sort of sponsors, just you guys, right? And then of course the stream is down here at the bottom as well. So that is kind of the introduction there. And what we're working on right now is we are working in the context of something called Illumina, which is actually the first game that we are working on building. So the full title of the game is called Shadows of Illumina, but I've called the project just Illumina for short. And so the way that this basically works is that the game project itself consumes the engine and uses it. And we are setting up some of our basic things in our game project. One of those things being, we are moving away from a render graph system that was very generic but also kind of heavy to a bespoke renderer type of setup, right? So the idea being that the application, the end application that's using the engine, knows what kind of data it's going to be dealing with. It knows, how things need to be rendered, how that data needs to be organized, how it needs to be transformed. And so it makes no sense to do super generic things at the engine level when we're going to have to, essentially override that at the game level anyway. Why not just do it at the game level and avoid all that generic crap, right? All the overhead, code complexity, all the things that go along with that. And so we're moving away from this render graph setup, which basically was configured via a proprietary storage format that we have here. But we essentially set up a render graph, and we had all these various nodes that could be connected together with sources and sinks and all this kind of fanciness. And this was kind of a cool exploration, right? But ultimately, we're moving away from this because it's more than we're really going to need. We don't need this kind of super flexible stuff. We can just kind of do it in code and not have to have all of the overhead of setting this stuff up and figuring out and building up a whole bunch of stuff every single frame to support this, right? So that is kind of what we are in the middle of doing at the moment. Daniel, hello again. Vulkan, my beloved, yes. Yeah, we are using Vulkan. And I am on Arch at the moment. So we do support Windows and Mac OS, but I primarily stream from Arch, by the way. Most I've made a triangle move across the screen in Vulkan. That's fair enough. I mean, it actually takes quite a bit to get to that point. So that's not terrible, right? Super interesting. Sadly, I'm not at the level to even try and build an engine. So, cool part about that is we actually have the entire backlog of all of this complete series on YouTube. So one thing I did forget to mention was this actually started off as a tutorial series on YouTube. Let me see if I can find. Did I close the window? No, I didn't. So this actually started off as a tutorial series on YouTube, and at some point we basically had decided that we outgrew that format, right? And we switched to live streaming. But The very beginning of it, all the setup and all that stuff, is in tutorial format, and it starts off in very digestible, sections. Some of them much longer than others, obviously, right? We try to deep dive into things without going too crazy with it. But I need to actually update this playlist because this is much larger than 272 videos at this point. I update it every once in a while, but looks like we stopped here at episode 194, which doesn't make any sense. I just think maybe this thing stopped loading because I know we added stuff after that. But anyways, that's kind of the gist. Let's see. So no plans on making some income from this project. So, couple plans I have there. I mentioned that the engine is going to be free and open source, not the game code though. So the game code, I do eventually plan to release, but the game code is not going to be released until after we release the game, in some period of time after we release the game. And so at some point I will make this publicly available, but the game code itself is not available. It is not open source. That being said, I am going to use this game code, or at least some of the stuff that I'm scaffolding now, to set up certain templates to go with the engine so that it's at least usable. But as far as the actual game code that we're creating here, that's not going to be available. And so, that's kind of my plan is I'm going to sell this game on Steam once we get to that point, but that's quite a ways off, right? The other thing is, of course, I've got like the Patreon up there and the YouTube memberships and Twitch subscriptions and stuff like that. So I do make a little bit, certainly not a lot, but I do make a little bit from that, which is nice. And that helps me cover the costs of like, things like hosting fees, software licenses, that kind of thing. But yeah, that's kind of the plan with that there. Let's see. And in case I don't think I really gave an overview of the game too much, there's not too much to go over, but the game we are building is a 3D isometric action RPG. So we're going to be designing that. We're going to be designing that on stream as well. In fact, let me pull up something off screen here real quick. I'll show you guys some of the design we have. Give me just a moment to pull this up. All right. Come on, load, do the thing. All right, I'm gonna let this load off screen and then I can pull it down so that you guys can see it. Okay. So we kind of have this design document that's available here. And this has a whole bunch of stuff, some world building, a little bit of lore, all the different races that we're going to have, the different religions we're going to have, the different capital cities, things like that, and a little bit of backstory on that. We've got 30 pages here worth of stuff that we've already kind of laid out for this. We've got some notes in here about some mechanics we want to sort of drill into a little bit. Combat mechanics, world mechanics, crafting, different types of weapons and gear and other stuff like that. Magic, some UI and mechanics ideas, control schemes, stuff like that, and some of the stuff that we need in the engine to go with that as well. So we've got that. And then we also have this world map that I've been sort of building and working on. You can tell it's definitely incomplete, but we've got quite a lot of stuff developed. We've got 3 continents, and we've got some cities and little towns and landmarks and things like that. And so we have quite a lot of work done here too. And this is ultimately the world that we're going to be building in game, right? So that's just kind of to give you guys a little bit of taste of what that's all about. Thank you for the sub over there on the YouTube side. Appreciate that. All right. Gotta admit, render graphs are cool. They are cool, right? It is really neat to be able to just configure this stuff in text, but there's so much code overhead that goes into being able to do this that it's just not worth it for our stuff, right? If I was making this to be a super generic engine that you know, was maybe a replacement for Unreal or Unity, and I was trying to compete in that space, you know, maybe we would consider keeping this, but I'm not competing with that because I'm one dude, right? So, what is being done for user-defined shaders? So right now, the shaders are written in GLSL and sent to the rendering backend to be compiled. And so that's going to work, obviously, for Vulkan, right? But what we're going to do is we are going to, when we start supporting the other rendering backends, we are actually going to come up with essentially our own shading language that's going to sit on top of that. And then depending on what rendering backend we use, we're going to send that through, transpile that to whatever that needs to know, whatever, you know, whether it's SPURV for Vulkan, or, you know, MSL for Metal, or HLSL for Direct3D. We'll have translators in the rendering backend for all of those things. Let's see. What did you do to reach this level? Read CS degree apprenticeship. So I do not have a CS degree. I have, and I didn't do apprenticeship either. I did build game engines professionally for 5 years. But most of all of this stuff, as far as like 3D rendering and stuff, because the engines I built professionally were all 2D engines. You know, all this stuff is just self-taught, and I've just been doing it for a long time. So yeah, which goes to show, you know, in order to actually do this stuff and figure it out, you don't need a degree. Just saying. Big investment of time. Yep, it is for sure. But to be good at it, to be good at anything like this, that's super technical like this, it takes time. Do you think ShaderX textbooks are still relevant, or should I invest my time on GPU Pro texts? I can't speak to either because I've never used them. So unfortunately, I can't speak to either one of those. I have learned Vulkan and GLSL by reading the spec, which is probably the hard way to do it, but ultimately I understood it better from doing that. Okay. CS degrees are mostly theory. That's true. Yep. Practicality or practical application isn't really a thing or part of that. Yep. Best teacher is yourself. You're doing all the work. 100%. Shader Toy is a good way to get started with shaders. Absolutely agree with that. Yes. I've used that to an extent. Although now I kind of have this framework, I can kind of do it in here. Guess I just got to dive into it and write a blog on them later. Yeah. Yeah. RTM for the win then. Yep, exactly. Read the manual. 100%. The advice I always give about learning to write a Vulkan renderer is read the Vulkan spec. Maybe start off reading a tutorial, right? Start off that way. But if you really want to get good with and understand Vulkan, read the spec. And the spec is long, right? Read the spec, write a renderer. Throw the renderer out. Read the spec, write another renderer. Throw it out. Read the spec again, write a renderer. Throw it out again, repeat, right? The only way you're going to get good at it is to keep doing it. But don't save what you've done previously and just kind of patch things together. No, throw it out and rewrite it from scratch. And every time you do it, you'll get much faster at it. And it'll help things stick up here. Trust me, I have the memory span of a goldfish. Just ask my wife. That's the only thing that's the only way stuff sticks. It's just constant repetition. Someone almost done with my degree. A lot of it you have to teach yourself, 100%. And that continues tenfold after you leave college. Okay. So basically, the process that we've been following here is I've been looking at this render graph configuration and going node by node, right? So each one of these represents a node, and I've been recreating what those nodes do in this order because I define them in the order they need to be, even though they don't need to be as far as this is concerned. But as far as our renderer is concerned, it needs to be that. So our bespoke renderer, I've gone through these one by one and just recreate them, and I'm scoping them all, right? And so we've done the frame begin, clear color, clear depth stencil, shadow pass, our forward rendering pass. We just did our debug 3D. We still have to do editor Gizmo. That's actually the last one we have to do. And then I did the standard UI already. And we have our frame end, which is also already done. So this editor Gizmo is the last one that we actually have to do. And then we actually have to go ahead and place in all the hooks into this renderer in our game code and actually change our game code over to use this and generate the data that this needs instead of trying to pass it all off to the render graph. Let's see. Rinse and repeat. You'll learn eventually how to throw out your renderer. Yes, that's true. It's true. Great thing about CS is because which is a great thing about CS because you only need a laptop. Yeah. Flask, good to see you. How's it going? What was that website? Book of Shaders is a good guide for writing shaders. I have seen the Book of Shaders. Yeah, I think it is Book of Shaders. The Book of Shaders. This one. Thebookofshaders.com. Yeah, so this is another pretty good resource as well. It's not complete though. Right, but it's got some decent stuff in here. So it's another resource you can look at. I'll drop a link to it, and yeah, I mean, all you really have to do is just is search for it, right? And you'll find stuff. Okay, so render graph, node, editor, Gizmo. Let's see. This is oh, I renamed this one backwards. What a dingus. Okay. I was like, why isn't it showing up? Because I called this one editor Gizmo render graph node instead of render graph node editor Gizmo like all the other ones are. Good thing we're deleting it. Okay, so if we examine this guy, we need to create or at least replicate a few things. So we need to do our setup of our internal data, but let's see, we can skip all of this stuff. We don't need any of that stuff. We don't need any of this. We don't need any of this stuff. So actually, yeah, we can skip all the render graph sources and sync logic. Actually, there's not a whole heck of a lot we have to do for initialize, right? Or for creates, rather. So we do have initialize, and then we do have a load resources as well. So let's go ahead and check out initialize. So again, this is actually using our debug shader as well. So this logic is most likely going to be very, very similar to what we just did for debug, which is kind of why I left this one for last. So that's going to be the same. And then we also just need to, in addition, acquire a per draw ID for this. So that's not a huge deal. And then let's see, load resources is literally just getting the color buffer texture, which we're already going to have, so we don't even need to bother with that. So we just have to worry about initialize and then obviously the execution. So the execution is going to be really straightforward, actually. And we can see we've got some to-dos in here. talking about, making the Gizmo, a constant size and whatnot. But we don't have that set up, but we can actually just move all that to-do stuff over so that we don't have to worry about it. Okay. Annoyingly, this one uses our X forms. So we're going to have to... We should probably pass this in and just pass the model matrix to the renderer. We shouldn't actually have to do this within our renderer. So we are going to have to split some of this up. And then the other thing that we have is we have these K geometries, which is fine. So we grab a pointer to that geometry, and then we use that to generate geometry render data, which we're not going to do, to call this, which we're not going to do also. So we're going to have to take the execution code part a little bit, but that's not a huge deal. All right, so I think what I'm going to do is I'm going to go into this guy, and we're going to essentially, we're going to copy pasta this, because it's going to be almost the same. But we're going to have to obviously change some stuff. So we have this in our Illumina renderer. We have the SUI pass stuff already. So I'm just going to go to this structure here. And, whoops, I don't want the SUI one. I want, I just realized I copied the wrong one here. I want this one. And that needs to be here. So this is going to be editor Gizmo pass state, right? So we're going to go here to this structure. We're going to create a copy of this guy, and it's going to be the same structure, but I'm going to keep it separate anyways, because there's a possibility that we may have to, there's a possibility that we may have to change the state of this, right? So we're going to do editor Gizmo, right? And then I'm going to take that and come down here, and we're going to paste this, and we're going to say editor Gizmo pass, right? So that's that. And so now we can actually change this to editor Gizmo pass. We're going to use the same shader. We're going to use all of the same. We're going to use all of the same uniform locations. The only thing we need to make sure to change is, instead of world debug pass, it needs to be editor Gizmo pass here. Right, so we just have to make sure to change that, and that's it, right? That is initialized now. Now, we need to do render, and I think we could probably just go to world debug pass, and I'm actually going to, you know what, I'm not going to copy this. We're going to have to redo some of this, but I think I want to avoid copy pasta errors on this one, right? So I think what I'm going to do is I'm going to come back over here to our render graph execute, and we're essentially going to take just the data that we need. So I guess we'll grab Gizmo, and then all the way down here to render and debug level, right? So we just shove this back off to the side, right? And we'll basically, we'll will basically go ahead and fill this out and convert it to do the correct thing. Let's see. You're witnessing throwing out the renderer in action as we speak. I mean, kind of, yes, but I'm not throwing out the Vulkan renderer. The Vulkan renderer, thankfully, has been pretty stable. I don't have to modify it very much anymore. And when I do, it's pretty minor. Let's see. What are you doing? Yeah, I'm rewriting a renderer for my game. I guess not rewriting it. We're writing it, right? We're kind of shutting down or getting rid of our render graph, and we're setting up a bespoke renderer instead. And the advantage to doing this also, by the way, is all of our rendering logic for the entire application is in this one file. And it's a whopping 1,100 lines of code, right? So it's not very much code at all. All right, so editor Gizmo. We're going to go ahead and include this for now, but what I'm going to do is I'm going to put a to-do in here. Should only be included in non-release builds. Right, because there's zero reason for us to have the Gizmo in release builds. In fact, instead of a to-do, I'm going to have this be a fix me. So it's a little bit more urgent. Okay, so the other thing that we're going to have to set up is obviously our render data coming in for the Gizmo. So if we take a look at what we need, we have, let's see, the editor Gizmo. But let's see, why do we need the Gizmo, right? I would argue that the renderer probably does not need the Gizmo. Editor Gizmo render frame prepare. Okay, so I think we need to take a look at this function. See what that does. Because I feel like we shouldn't have this back and forth between the renderer and the editor Gizmo, right? Ultimately, what we want to achieve here is if we can do it, I want to actually, instead of passing the editor Gizmo in here at all, I just want to pass data that the renderer understands, ultimately geometry data, or really just vertex and index buffer offsets and counts, right? And so let's see, we have a begin rendering here. That's fine. Okay, so we're going to need a viewport, obviously the color shader and all that stuff. So we're going to have a view, projection, and I assume a model matrix. Yes, a model matrix. And then some geometry render data and a draw ID. Okay, so that's not a crazy amount of stuff, right? So there's zero reason for us to actually have to do this, right? We don't actually need the editor Gizmo here. The only other thing I want to look at is if I can type it correctly. Is I want to check out what this editor frame prepare is. Render geometry vertex update. Okay, this should be done. This should be done before we get to the renderer. Because essentially what this means is that we may have done some sort of update to the geometry of the Gizmo. So for example, whenever we hover over one of the elements of the Gizmo, we turn that geometry, or that portion of geometry, yellow, right? And then when we leave it, we turn that back to its original color. And so that's an example of one of the things that we might have to do. But there's zero reason for us to be calling that from the renderer. So, all right. I am going to actually remove this from here. And I'm going to put over here a note. this should be done in the application before the renderer is called. And I'm going to no check in this. All right. That way I don't accidentally push the code that isn't fully complete with that understanding. Okay, so we need to actually create some render data, right? So I guess probably the way to do that is going to be, let's see, let's go to our Illumina render data, and right next to debug pass, we're going to do, actually we need a new structure, which again is actually going to be fairly similar to this one for our debug pass with a few changes. So this is going to be, let's see, what do we got? Editor Gizmo. So this is going to be the render data for that pass. So we'll go ahead and just replace that. So we need projection, view, and model. We need a viewport. We don't need a geometry count because we only have one geometry, right? And this is debug geometry data, which also contains our draw ID along with the geometry. So we can actually keep that. It just needs to be a single geometry, right? Okay, and this is actually wrong. Okay. All right, so we take this, add it to our render data, and we'll call that editor Gizmo data. Right? And so in that, that is essentially what we're going to sort of work our way through. So we don't need that, right? The debug label that we're going to put in here is editor Gizmo, right? That's just for render doc, right? Internal data enabled. Okay, so this is a good question, right? Because we may or may not have editor Gizmo data to render. The only time that the editor Gizmo should show is if it's actually marked as visible, right? So I think what we might actually need to do is actually create another variable in here. I usually hate doing this, right? But I'm going to throw a Boolean in here for now. And we're going to say, do I want to say enabled? Visible, right? So we're going to do render data, editor Gizmo data visible. Whoops, visible. Why is that not? Didn't I add? Where did I add that? Oh, what a dingus. I put it in the wrong struct. Okay. Really? What is this bleating about? Illumina editor Gizmo pass render data. No member named visible. Right, so editor Gizmo data is this guy. We go to definition on that, visible's right there. What is this talking about? Oh, okay. Apparently IntelliSense was just tripping. Okay, so The texture handle we need to get is going to be from renderer, and that's going to be color buffer. Right, so that's all we need there. And then begin rendering. We're going to have a few of these as well, I think, but I'm just going to go ahead and do this one here. Renderer states, and then this is going to wind up being render data, editor gizmo data VP rect, right? And then this is also going to be render data editor gizmo data dot VP. Did you see that the Cherno moved his engine to NVHRI or RHI? Yes, I did see that. However, I did actually earlier today, I watched something on that he was talking about because I was interested to know how it was coming along. And he talked about something that basically was a deal killer for me ever using it. And that is, it basically goes buck wild with dynamic allocations internally. That's a deal killer for me. Not doing it. It's basically got like a garbage collection thing going on inside of it that they built. That, for me, completely killed it. I do not want anything like that inside my engine. Nope, 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 nope. It sounded cool on the surface, but yeah, that killed it for me. All right, so we need let's see, renderer, editor gizmo pass dot color shader, and we actually have a few of these that we can just replace. A couple more here. And then we have one more renderer thing here. All right. Garbage collected what? Yeah, exactly. It's got a garbage collector inside of it. He was talking about it, I think in the video he released. It was either came out today or yesterday, I want to say. But yeah, it literally has a garbage collector in it. Yes, thank you, Skyob. Yeah, people, like, at that point, why even use CPP? People are too afraid of memory management. Yes, I agree. How do you handle memory allocation in your engine arenas? Yep, essentially. We have custom allocators that I use. GPU or CPU GC? It was all on CPU, I believe. Although I think it also handled some GPU resources as well, but also the CPU side resources that back that. As soon as I saw the words garbage collection in there, I was like, nope, done. Not doing it. All right, so I should see if I could actually find that video and link it. I won't spend too much time looking through it, but I think it was, yeah, I think it was this one. I'll drop it in chat. I think he talked about it in here somewhere. I don't remember exactly where it was. I'm going to mute it so that it doesn't play in the background. Let's see. Where was that? Let me see if I can find it. I'm going to spend like just 30 seconds or so looking through this to see if I can find the exact spot, but here it is. Yeah. Yep. So at least that was my understanding of it, right? Anyway. You know, no hate there. It's just not something I don't want to use, right? I don't want to use it. Okay, so let's see. Debug locations projection. So this is going to be... why was that? Okay. I guess we'll do... editor Gizmo pass, and then we need projection location. By the way, if my understanding of that video is incorrect, please feel free to correct me. Wouldn't be the first time I've misunderstood something like that, so. All right. I was like multitasking and doing other things while I was watching it, so I wouldn't be completely surprised if I misinterpreted it, but I don't think I did. So we just need to convert these things. Render data, editor Gizmo pass, view. Wait a minute. Oh, data, not pass. Okay. So the next thing that we have here is the geometry, right? So we get a K geometry. I don't think we should do this either, right? In fact, I know we shouldn't do this because we actually set the structure up for it. So let's go fix me. Convert to bespoke renderer geometry render data, right? And I'm just going to put it like this so that's obvious what we're talking about, right? So instead of using geometries like this, it's going to be Illumina geometry render data, and we're going to have render data, editor Gizmo data, and then geometry. Actually, I guess we don't even... Yeah, I mean, it's a convenience pointer, I guess, right? Oops. Oh, it's debug, that's why. Okay, I need the debug in here, debug. Sorry for the microphone hit there. All right, so I'm going to keep these. Well, okay, I guess those are out of date, right? But we can leave these comments in here because I do need to figure this stuff out at some point. However, model, this is all going to be removed. So let's see. So instead of doing model here, we need to actually come down here, and this is again going to be render data, editor Gizmo pass. Oh wait, you know what? That's the location I need. Renderer, editor Gizmo pass, model location. And then model, instead of that, we're just going to have render data, editor Gizmo data. Model. Why is that? What did I miss here? Editor Gizmo data. I think there's just too many errors up here. It doesn't know how to handle itself. All right, so I'm going to remove all of this, right? Because we don't actually need that stuff. Let's see, scalar stuff. What are we doing here? Okay, we are going to have to switch this up a little bit. So let me take this. And come up here and do mat for model equals that, right? And then we can perform that. Okay. Let's see. Keep a copy of this for hit detection. Scale scalar. Okay. I can disable that because that doesn't really do anything at the moment. We're going to have to fix all that anyway. Okay. Let's actually also, my highlighting is kind of screwed up there, so I'm going to just put an extra line in there. Okay. So the draw ID is going to be render data, Gizmo data, geometry, draw ID. And then instead of doing this, we can actually come up here and just grab this block of code and replace this with that. And then instead of geo, I guess it's just going to be G in this case. I should probably standardize my naming here, but I'm not really that worried about it for now. All right, and let's see what this warning is. Right, because we don't need editor Gizmo anymore. Okay, so that is actually perfect timing for us to finish this up, because I'm out of time for tonight. Psycode, good to see you. How have you been? Oh, you guys have had quite the conversation over here in the last couple minutes. Okay. Doubt it's much of a hit because it's just recycling pools, but go figure. Yeah. Written by NVIDIA, so hopefully they have it well planned. I mean, you say that, but have you ever looked at the amount of allocations that they have in their what's the term? Validation layers? I mean, those need to be kind of performant too, but holy crap. Let's see. Use more memory because you need Q. Doesn't support tessellation, which is a bit of a deal breaker too. Oh, that's web GPU stuff. Okay. All right, cool. I'm not going to be able to catch up on all that. I am good, Psycode. Thank you for asking. Is this your custom NVIM? I mean, it's my configured Neovim. Yeah. So I have a Neovim config here. I'll link it for you in chat. I'll do it on both sides. But large asterisk for that. I actually went and updated a bunch of plugins today and a bunch of stuff broke. So use at your own risk. Because I think there was lots of changes to Telescope that broke stuff. So heads up on that if you go to use that configuration. It may or may not work out of the box. I haven't tried it in a while. Okay. NVIDIA sure makes cool tech, but I think AMD has better software engineers. I don't know about that. I've had mixed reviews of AMD's drivers as well, so. AMD has also historically provided much more useful hardware spec and information and tools, which is a plus, but they have other issues. Yeah, their issue. So AMD's hardware has always been top tier, right? The issue with them was always the software that backed it up was not always the best. Particularly back when they were ATI, right? Anyways, that is going to do it for the stream tonight. I'm going to find somebody to raid. Thank you guys for being here. I really appreciate it. I appreciate you guys being here. It was a lot of fun to hang out with you guys and interact and whatnot. And we got a bunch done tonight, which is a huge bonus. So next stream, we can actually work on tying this renderer into the application code, which is going to be pretty sweet. So let me find somebody to raid. And while I look for somebody to raid, if you guys haven't already, I would greatly appreciate a follow and or sub, either on the YouTube side or the Twitch side, or both if you're so inclined. They call it subscriptions over on the YouTube side, which is confusing when Twitch subscriptions are something different entirely. But anyway, let me find somebody to raid. Let's see. I think I know who I'm going to raid. I'm just going to scroll here for just a second. Okay. We are going to raid Falonir. He is the leader of the stream team that I'm on. So we're going to see what he's up to. And yeah, thank you guys so much for being here. And I will see you guys in the next stream. See ya.